In this video, we'll talk about how to estimate the area under a curve using a table of values. So I want to begin with an example. This says that a company's profit growth projections T months from now is given in the table. So this table on the top row keeps track of T, which is measured in months. And the bottom row keeps track of the profit growth, which is measured in millions of dollars per month. And part A is going to ask us to use the midpoint rule with the maximum number of rectangles to estimate the area under the graph. So two quick comments about this. So the first is, the question is talking about profit growth. And since it's talking about growth, that's talking about rate of change. And the rate of change is a derivative. So profit growth actually means it's talking about P prime, the derivative of profit. And the other comment is that some of these values in this row are negative. And what that means is that the profit is decreasing. At least the company is projecting that their profit would be decreasing here. And when is a function decreasing? A function is decreasing when its derivative, P prime, is negative. But that's exactly what this table is saying. The bottom row is the derivative, and these values are negative. It's saying that the derivative of profit is negative in these two spots. Okay, so let's talk about how we can use the midpoint rule here. So because I have a table of values, let's begin by plotting these points. So let's draw some axes. So I'll have a t-axis, and then I'll have a p prime axis for my rate of growth of profit. So on the t-axis, let's put 2, and then 5, 8, 11, 14, 17, and 20. So the values that we have. On the other axis, I'm not going to draw it to scale. Let's say that this is 20, and then I have 21, 22, 23, 24, 25 here, and then 26. And in the negative direction, let's say that this is negative 5. So plotting points now. When t is 2, the output is 20. At 5, we get 22, so 2 units up. At 8, we're up to 23, so it's climbing. At 11, we're all the way up to 26. At 14, we stay at 26. At 17, it drops to negative 5, so it drops below the t-axis. And then at 20, it's at negative 4, so it's a little bit higher. Okay, so looking at this picture, it seems like we've split this up into 6 subintervals. But if we were to think to use 6 rectangles, I need the midpoint of each one, because it's asking us to use the midpoint rule. But if I think about the midpoints, like the midpoint of 2 and 5, for example, I don't know the point. I don't know where the point is at this midpoint on the graph. So I couldn't use this as a rectangle. In other words, I can't use 6 rectangles. So we can't use 6 rectangles because there's not enough info on the graph to know what the outputs are at the midpoints if we were to use 6 rectangles. But we do have enough information for 3 rectangles. But we can use 3. So what would that look like? So if we were to use 3, so the first subinterval would go from 2 to 8. So delta x, this width, or I guess I should say delta t maybe, because my variable is t. Delta t here would be 6. And the next subinterval also has length 6. And the same with the last one, it also has length 6. So let's start with the midpoint of the first subinterval, which is 5. Draw until I hit the curve, which happens at that point. Then I draw a horizontal line for the top of the rectangle and lines down to finish off the rectangle. The next midpoint is 11. So I draw a line, dashed line until I hit the point. Draw a horizontal line for the top and lines down for the sides. So one different thing happens at 17 though. At 17, I have to draw down to hit the actual curve. Then I draw a horizontal line for the base of this rectangle, and then lines up for the sides. Okay, so let's start to write down M3, our area. So M3, so the base of the first rectangle is 6, and the height is 22. Next rectangle, the base is 6, and the height is 26, so I get 6 times 26. For the last rectangle, the base is 6 again, and because we had to draw down for that value, we had a negative value for the profit growth there, I need to keep track of that negative value. I have to think of this as sort of a negative area. Okay, so now if I factor out the 6, we get 6 times 22 plus 26 and then minus 5. And working that out gives us 258. Okay, so 258. So one important thing that I want to keep in mind there is just like we saw here, regions below, in this case it's the t-axis, but sometimes it could be the x-axis, give us negative areas. They get counted as negative areas. And we'll make this idea more formal later when we define a definite interval. The fact that regions below the x-axis, or in this case the t-axis, will get counted as negative areas, while regions above the t-axis, or in this t-axis or the x-axis in general, will get counted as positive areas. Alright, so let's do one more part to this example. What does the quantity that we just got in A represent? And include units. So I'm going to begin by just copying down the computation that I had from part A. Okay, so there's my computation. And I want to give you the opportunity to think about this first. So pause the video for just 30 seconds. See if you can figure out what this quantity represents. 4, 3, 2, 1. Pause the video. Pause it for 30 seconds to think about this on your own first. Alright, so hopefully you've done that. Hopefully pause that video for about 30 seconds to think about it. Let's talk about it together. So one thing that can help us is to really look at the units for each of these quantities. So 6 was unit of time. It was measured in months. Each of these values, the 22, the 26, and the negative 5, were profit growth numbers. Profit growth was measured in this problem in millions of dollars per month. So we're multiplying those. We're multiplying months by millions of dollars per month. And doing that, the months on the top here will cancel with this month on the bottom and just give us millions of dollars. And that's the unit of 258. This is 258 millions of dollars. That's a lot of money here for this company. And what this quantity represents is the net change in profit between whatever this time period is. Between, it was from t equals 2 to t equals 20. Between 2 to 20 months from now. So if our graph had looked a little bit different, for example, if this projection where it went below the t-axis had been a whole lot lower, maybe the overall area would have been negative. And if it had been negative, that would mean that the company is projecting that their net change in profit is negative. In other words, that they have a loss if they have a negative estimated change in profit. Okay, so there's a general idea here about areas under a graph. And here's the idea. In general, the area under a derivative graph, like this is the derivative of profit, the area under a derivative graph over some interval, I'm going to call it a to b, represents a net change in that function. In this case, it was the profit function, the original function, not the derivative. The net change in the original function from that starting point, t equals a, to that ending point, t equals b. Okay, so I'm going to box this because that is a big idea from this video. So in terms of our goals for this section, we've now talked about how to approximate area under a curve when given a table of values, and we've also talked about how to interpret what that means. In the next video, we'll introduce something called sigma notation, which is a shorthand notation to talk about sums.